Homework 5, question 2. So the question is the given fxy is equals to that 1 over capital A times y squared times x, and telling us that the y is bigger and equal to 1. 1 over y is smaller than x, smaller than y. And then for the question, draw the non-zero definition region of f, x, and y. So as you can see from the graph, the picture looks like this. So for the question 2, is saying find the value of a so that the fxy is a valid joint density function. So fxy is equal to 1 over a capital A times y squared times x. So it's equal to the integral from 1 to infinity, and then the integral from 1 over y to y, that 1 over a times y squared times x dx, and then after that in dy. So we know that the inside of the function is going to be just we can take the 1 over a times y squared out, and which is going to give us the integral of 1 to the infinity that times 1 over a times y squared times the integral of from 1 over y to y 1 over x dx times dy. So we know that 1 over x, the integral of that will be just the ln of x. So we plug in the number of y and then 1 over y to it. So the equation become the integral from 1 to infinity times 1 over a times y squared times the ln of y minus the ln of 1 over y dy. And now we take the constant out, and which will be y squared. The 2 will come out, and then the 1 over a will come out. So it's going to be 2 times 1 over a times the integral from 1 to infinity times ln of y over y squared dx. Now we set a w that the w is equal to the ln of y, and then so because w equal to ln of y, so y is equal to e to the w. Now so the equation become equals to 2 times 1 over a times 1 integral of 1 to infinity that w over e w dew. So is equal to 2 over a times the integral from 0 to infinity that w over e to w times e w dw, and it is equals to the 2 over a times integral from 0 to infinity times w e negative e w dw, and then we put the e out, and then so we get is equal to negative 2 over a and then times the integral of from 0 to infinity times w times de negative w. So we know this is equal to 1. Obviously we know the a is equal to 2. So for 3, find and draw the marginal density function fx and fy. So for fy, it's going to equal to integral from negative infinity to infinity fxy dx. So it's equal to 1 over y to y integral from 1 over y squared times x dx, and then it's equal to ln of x over y or y squared. So it's going to be equal to 1 ln. So fy is equal to ln of x over y squared. 1 y is smaller than infinity and bigger and equal to 1, and it's going to be equal to 1 otherwise. So the graph will be so the graph of fy will look like the one drawn on the slides. So for fx is going to be equal to from negative infinity to infinity fxy dy, which will be equal to integral from 1 over x to infinity 1 over 2 times y squared times x dy which gonna equal to 1 over 2 when now x smaller than 1, and then when x is bigger than 0. And then so for when fx is equal to x to infinity, integral from 1 over 2 times y squared times 2x dy is equal to 1 over 2x to the square when 1 smaller than x smaller than infinity. So the graph will be look like the one showing on the slides.